Mm, uh, Hello, teacher. Today, my group will present on e-commerce project. The topics will include reinforcement learning for automatic retail trading, and the group consists of members. The first members is Michael Fuchs, Miss, and another is Phan Nhật Hoàng, and the last person is Dương Huy Hoàng, and I will present about the introduction. And in introduction, we will have three topics. The first is background and motivation. The second is objectives and the scope of the project. And the finally is overview of the key component and technical views. Let's take a closer look at background and motivation. And automated crypto trading has gained significant popularity due its potential to generate profits and minimize human bias in decision making. And crypto trading is a complex and dynamic and this reinforcement learning techniques such as Q-learning offer promising avenue for crypto trading strategies. And Q-learning is more of reinforcement learning algorithm that learn an optimal policy by iterative update the action value function based on the options required. And by using Q-learning, an automated crypto trading system can adapt and improve its decision-making process over time. And one of the advantages of using deep reinforcement learning technique is learn hero to high design and non-linear nature of crypto market data. And these neural networks implemented using frameworks like TensorFlow can effectively process and analyze large amounts of historical market data to identify underlying patterns and trends. And this reinforcement learning technique can capture the dynamic nature of the crypto market by learning from past experience and incorporating real-time market data. Pure learning with TensorFlow enables the system to make more informed and data-driven trading decisions. And the conclusion, the combination of Q-learning with TensorFlow in automated crypto trading holds the potential to overcome the limitation of traditional approach. And next up, we have objective and scope of the project. The objective of the project which develop an automated crypto trading system using Q-learning and TensorFlow 2.0. The first is design and implement a Q-learning algorithm that utilize a neural network and train the model using historical crypto market data to learn optimal trading strategy and integrate the Q-learning algorithm with real-time market data. And the second is to evaluate the effectiveness of the automatic crypto trading system. And the scope of this project is crypto market focus. The project will primarily focus on trading crypto in specific markets, and the system will be designed and optimized for the dynamic and characteristics and the data consideration. Historical crypto market data will be used for training the learning, and real-time data will be incorporated to enable adaptive. And the project will explore alternative data such as new estimation. And some limitation is the project will focus on developing and evaluating the automated crypto trading system, and will not provide finance advice or guarantee profits. And the project will not consider transaction costs, tax, or regulatory requirement. And the system performance will be evaluated based on historical data and simulated trading, and its future performance may vary in live trading conditions. And the final is topic 1 is overview of the key component and technical use. The first is neural network model implementation, and the TensorFlow library is utilized to implement the neural network model. The code import the statutory models such as NumPy, Pandas, and specific components from TensorFlow podcast to facilitate model creation and training. The model is constructed using the Keras API, defining the input and dense layers that constitute the architecture of the neural network. And the second technical visual is API API integration. The API API is incorporated to enable connection with the API trading platform. The code import the REST stream and other necessary modules from the API API library. And types such as market order sign, or time influx for managing trading order. And the next slide highlights the literature review. Literature review has 3 topics. The first is review of relevant literature on reformer learning and Q-learning. The second is application of Q-learning and TensorFlow 2.0 in crypto trading. And the final is identification of gaps and limitation in existing of right. And review reformers learning and Q-learning. We focus is based on Q-learning, popular model-free reformer learning and curriculum, and we divert into the field of reformer learning, providing an overview of its technical and application, and we explore the theoretical foundation and key concepts of Q-learning, include the action value, function, and exploration. It's pollution trade-off. And the application for Q-learning and TensorFlow, we investigate prior study and research, employ Q-learning and TensorFlow 2.0 within the domain of financial market. Specifically, the group used is crypto trading, and we examine the different approaches, architecture, and the studies showcase how Q-learning algorithm interacted with TensorFlow and decision making project, and the identification of gap and limitation in this. We bring and this brings us to our next point is identification of gap and limitation in existing approach. And step one, we identify any gaps or limitation in the current approach of applying Q-learning and TensorFlow 2.0 in crypto trading. And step two, this analyst has to identify areas where further research and development are needed to overcome existing challenges. And the step three, we also consider the limitation and bias in the review theory and providing insight for future investigation. And now let's shift our focus to methodology. And the methodology is that contain the planning algorithm, the second style representation in action space design, the third is request function, and the fourth is exploring, the final is exploring exploitation strategy and learning parameter. And the next slide is to illustrate is about Q-learning algorithm for crypto trading. And we provide an explanation of Q-learning algorithm. And the adaptation of Q-learning for crypto trading involves formulating the problem as a back-cost decision project and learning an optimal action value function through iterative updates. And next slide, we explore this idea further with the state representation and action space. And we will discuss the design of the state representation. And the state include variables such as number of shares owned for each crypto, the price of each crypto, and the available cash for trading. The action space is designed to accommodate the three possible actions for each crypto: sell, hold, or buy. And the reward function we will describe the formulation of the reward function. The reward function is designed to incentivize profitable trade and penalize unfavorable trade. And we will discuss the shaping of the reward function to guide learning project toward improved trading performance. And the final move on to the C, to slide to see exploration strategy and learning parameter. And we will provide an overview of the exploitation in reinforcement learning and its significance in crypto trading, and various exploration strategies such as excellent reading and employed to balance between exploring new action and exploiting the learning knowledge. And learning parameter including the discount factor and learning rate and turn to optimize the convergence and stability of the learning process. And the next slide, and we will bring us to our next point in data collection and reprocessing and Your learning model topic is Nhật Hoàng will present.
Hello everyone, my name is Tom. Today I'm very excited to present in chapter 4 and chapter 5 of our project. The chapter 4 is data collection and pre-processing. The data collection and pre-processing include three parts. Part 1 is data collection, process, and choose. Part 2 is data pre-processing.
Nhật Hoàng, we don't see the slide. Can you share again?
Okay. I will continue my presentation. The data collection process and source. The step 1 is identify data source. We conduct through research to identify rebuildable source of historical crypto market data. One of the sources we utilize is Yahoo Finance, well-established platform known for its extensive collection of historical crypto data. The next is access data source. The Yahoo Finance is identified as a data source. We leverage their platform to access the research historical crypto market data. This involves utilizing the available API or data download feature provided by Yahoo Finance. The next is retrieving data. Using the Yahoo Finance API or data download feature, we retrieve the requirement historical crypto market data. The next is data validation and cleaning. After retrieving the data from Yahoo Finance, we perform validation and clean produce to ensure data integrity. We check for missing or erroneous data point and handle them appropriately. The final of this part is data storage. We collected historical crypto data from Yahoo Finance is securely stored in our data storage infrastructure. We implement proper data management protocol and ensure the confidentiality. The second part is data pre-processing phase. We will cleaning the data. During the data pre-processing phase, we employ various techniques to handle missing value, outlier, and inconsistent in the collected historical crypto market data. Our approach involves identifying and addressing incomplete or erroneous data point to ensure the data set integrity and quality. Missing value are inputted using appropriate methods such as mean imputation of a forward filling outlier in consistent data point carefully disseminated and either corrected or removed based on the project specific requirements. The second step is data normalization to ensure the comparability of features used in our Q-learning model. We apply data normalization technique. This process prevents feature with a logic magnitude from dominating the learning process. The next step is feature extraction to enhance the learning capabilities of our Q-learning model. We extract relevant feature from the raw historical crypto market data. This involves calculating additional indicator or statistical measure that capture essential characteristics of the crypto market. The final step is data splitting to accurately assess our model's performance. We divide the pre-processed data into training and test sets. The data is split in the ratio of 75 and 25, allocating 75 of the data for training and 25 for testing. This divide ensures that the model is trained on designed period of historical data and evaluate on a separate period. Simulating real-world trading scenarios. Careful attention is paid to logically separating the training and testing periods to avoid data leak and provide a reliable evaluation of the model's performance in unseen market conditions. The third part is utilization of the Yahoo Finance ABI. The ABI integration. We integrate the Yahoo Finance ABI into our data collect system by utilizing the available API endpoint and methods provided by Yahoo Finance. It allows us to programmatically interact with their platform and retrieve the historical crypto market. The authentication. To access the Yahoo Finance API, we may need to set up the authentication credential system, API key or token with authentication process ensure that we have authorized access to the data and comply with any user invitation or term set by Yahoo Finance. The third is that data retrieval. Using the API endpoint and parameter, we specify the crypto of interest, the leisure time, range, and any specific data attribute required for our project. We make API call to retrieve the historical crypto market data based on the parameters. The next is data parsing and processing. When we receive the data from the Yahoo Finance API, we paste a process it to extract the relevant information to our automated crypto trading system. This may involve cleaning the data, performing normalization or feature extraction, and organizing it in a suitable format for further analysis and model training. The real-time data update in additional to historical data, the Yahoo Finance API also provide real-time market data. We can leverage this feature to keep our trading system to date with the latest market information, allowing for timely decision making and trading execution. The next chapter, we will present the Q-learning model design and implementation using TensorFlow. The first is detail on the implementation of the Q-learning model using TensorFlow framework. The second part is because of the TensorFlow achieve and design tools, including narrow network structure. Explanation of how the model incorporates state action and required representation. Overview of the training using TensorFlow includes the optimization algorithm and hyperparameter tuning. The first is detail on the implement of the Q-learning model using TensorFlow framework. The step one is create the Q-learning model architecture. The MLP function define a multi-layer perception model using the Carrot API of TensorFlow. It takes the input dimension number of hidden layer and hidden dimension as input parameter. The second is initializing the DQN agent. It takes the state size and action size as input parameter. The agent initialize the reply buffer, discourage exploration rate, and all the hyperparameter. It also create an instance of the MLP model. Updating the replay memory, and the update replay memory method of the DQN agent responsible for storing the current state, action record, next state, and down flag into the replay buffer. The next step is choosing an action. The add method of the DQN agent class
action based on an epsilon grid type. It is to a random action with probability epsilon, or select the action with the highest Q value predict by model for current state. The next is training the agent. It sample a part of experience from the reply buffer and perform an Q-learning update using payment equation. The next is loading and saving the model. The load and saving method of the agent class are used to load and save the model way respectively. The next is playing one is used. The flag one explicit function simulate one species of the crypto trading environment. It takes the agent environment and flag indicating whether it's either training or testing species. In each step, the agent select an action, perform the action in the environment, update the reply memory, and transition to the next state, the export, and and when the done flag is true, the final step is main execution. The code in the if name block set up the configuration parameter, load the data, create the environment scalar and agent objective, and run multiple episodes of training or testing. During training, the agent way and scalar the shape at the end. The second step is discuss of the TensorFlow architecture and design tools, including neural network structure. The first is MLB structure. Input layer, hidden layer with real activation, and output layer linear activation. The hidden layer, the number of hidden layer and their dimension can be specific and parameter when creating MLP. Additional hidden layer can be added by increase the value of a hidden layer parameter in the MLP function. The action function is relinear unique activation is used for the hidden layer. A commonly used activation function that introduce non-linearity and help the neural network learn complex pattern and in the data. Loss function and optimizer. The loss function use the MLP, the mean square error. The model compilation. After define the neural network architecture, we model is combined using the combine method. The next step is explanation of how the model incorporates state, action, and record representation. State representation. The state in the learning model represent the current environment of crypto market conditional. In the provide code, the next is action. The action in the learning model representation, the decision made by the agent at the particular state. The next is record representation. Record in the learning model representing the immediately benefit or penalty received by agent after taking an action a particular state. The final is training process with TensorFlow. Reply buffer. The training process utility reply buffer to store the agent experience. The reply buffer store tuples of state, action, record, next state, and done. Representation, the agent's interaction with the environment. This buffer allows the agent to sample and learn from past experience with improve the stability and if efficiency of the training process. The next is deep learning network architecture. The learning network model is implemented using a deep neural network architecture. The next is optimization algorithm. The optimization algorithm used in training the learning model is ADAM. ADAM is a popular optimization algorithm that adapt the learning rate based on the gradient update. Improvise code. The next step is hyperparameter tuning. The hyperparameter tuning are crucial in training the learning model effectively. Some important hyperparameter include the decal factor. The decal factor determines the way given to future report learning Q-value update. The exploration rate control the balance between exploration and exploitation based on the learn Q-value. Hyperparameter tuning involved experimenting with different value to find the optimal combination that lead to better learning and trading performance. That's my presentation. The next presentation is Mr. Yoon Hee Hoài will talking. Yes. Mr. Yoon Hee Hoài. Can you
see the screen? You see it? Can you see it?
I
see the slide. You see the slide?
Yes. I see the slide.
Oh.
Can you turn on the micro? I don't hear what you say.
Okay, Huy Hoàng resist. And then the next slide.
Hello, do you hear me? Hello.
Okay, I can hear your voice.
Okay. So I'm going to talk about the deployment process, risk management, position sizing, and transaction cost, the evaluation of performance and practical use, and finally is ethical and regulatory consideration. The deployment process of our automated pivot trading model in a real trading environment involves several key steps to ensure effective execution. First, we're going to use the Alpaca trading platform. We need to create an account and retrieve the key, the secret key and public key to use the API. And for the API connection, we establish a connection between our model and the Alpaca API. This connection allowed our model to access real-time market data and submit trading order to Alpaca platform. The data we're gonna retrieve through Yahoo Finance, which is much faster and easier. And I'm gonna show our program. Does anyone see the screen?
Yes, yes.
Here the dependency that we provide. This is Alpaca. This is the Yahoo Finance to make the data to cheat the data market. And here is the config argument. We're gonna need a get balance function to know how much money do we have, and we want this function is gonna calculate how many stock can we buy with the given money we have. And here is the buy and sell function, and this is the function that helps us to know the latest price. This function will gonna take an episode. This is our neural network. We have 3 layers: an input layer, one hidden layer, and an output layer. And this is the environment for our model to work on. And this is our deep learning agent. For the episode, we're gonna use 25 episode, and batch size is 32. And here is the chain loop. We're gonna retrieve the current time and to make the order. And the second topic is the consideration for risk management, position sizing, and transaction cost. For the risk management, we implement strategy to mitigate potential losses and protect our trading capital. For the position sizing, we carefully determine the appropriate position size for each trade based on factors such as risk-reward ratio, account size, and portfolio allocation. The transaction cost will take into account transaction costs associated with executing trade, including brokerage fees, commissions, and slippage. Next is evaluation of performance and practical use. Backtesting. We conduct rigorous backtesting using historical data to assess the model's performance under different market conditions. Backtesting allows us to simulate trades and evaluate the model profitability, risk-adjusted return, and other performance measures. Live trading. We deploy the model in live trading scenario where it interacts with the market in real time. We monitor the model's performance, including its ability to execute trades accurately and its overall profitability compared to benchmark models or baselines. and performance metrics, we analyze various performance metrics such as analyze return, shot ratio, maximum drawdown, and win-loss ratio to evaluate the model performance. The next one is some other factor is ethical and regulatory consideration. We want to ensure that our trading strategy and action comply with ethical standard and do not engage in any form of market manipulation or insider trading. We adhere to the relevant regulation and compliance standards set by the trading authority, ensuring that our trading activity are within the legal boundaries and requirements. The last one is transparency and accountability. We maintain transparency and accountability in our trading operations by documenting and recording all trade strategies and decision-making process. This helps us with complying with reporting and audit requirements and facilitate transparency in our trading activity. And the last one, conclusion and future work. Throughout the project, we have developed an automated crypto trading system using the Q-learning algorithm, particularly the deep Q-learning algorithm and TensorFlow framework library. For future work, we need to enhance our models, investigating advanced neural network architecture, incorporating additional features or technical indicator. And we want to develop a risk management strategy, more sophisticated risk management techniques such as dynamic portfolio rebalancing, incorporating risk factor or optimizing position sizing algorithm. And for the real-time data integration, integrating real-time market data into the model could enable more timely and accurate decision making, allowing the model to adapt to changing market conditions and improve trading performance. And here's our paper that we find through our projects. And thank you for listening to our team presentation.
Okay, chef recording.
I will stop record.